Alright, so now we come to the third part of the video for today's asynchronous lecture. Okay, so now we have another example 7. For number 1, for this example 7, it is somehow similar to what we have discussed in example 6, okay, where it is mentioned here for the graph gx. Okay, find the following limits if there exist. Okay, the graph g as shown here. All right, so as what we have discussed, or I have explained to you, to determine the limit from the graph, all you need to do is just to first find out limit from the left, then determine whether it's the same or not with the limit from the right, then you may conclude, right? So in order to know whether you understand or not what is going on now, I want, instead of for me to solve this number 1, I want you to try first. Okay, so this example 7, number 1, I want everybody to try first and show your solution in a piece of a paper and upload your solution at the Google Classroom. Okay, I'll open up the submission, okay, after the class end, for after our asynchronous class end, then the submission due as usual 11:59 p.m. tonight. Okay, all right, but for number 2, I'm going to discuss with you all. Okay, so this example number 2, find fx as x approaching 4. Okay, if fx, okay, as fx equals to root of x minus 4 if x more than 4, and 8 minus 2x if, okay, please take note everyone, maybe for those who download the notes somehow later in Thursday last week, okay, you already got the correct version. But for those who straight away download the note when I told you all that I have uploaded the notes, you may find there is some mistake here. Okay, so mine here is also the not the revised version. Okay, so I'm gonna make the correction now. So this is not x less than 0, but this is supposed to be x less than 4. Alright, take note. I'm not sure which version of notes you have. If you just download the notes at Google Classroom, then you already have the correct one. Or else, maybe yours is still for x less than 0. So please by key, jadikan dia x less than 4. Alright, so this example, okay, take note everyone, x less than 4. Okay, so there is no graph given, but instead it is given to you a function defined as this one. Okay, we have two sub-functions, one for x more than 4 and the second one is for x less than 4. Remember, when we want to find the limit of a function, what we got to do, we have first to find limit x approaching 4 from the left, right? Okay, limit of x approaching 4 from the left. So if it is from the left, meaning that it corresponds to x, which function, the first one or the second one, x less than 4 or x more than 4. Remember when I said, let's say this is 4, this one is coming from the left, right? This one is coming from the left. It indicates that this is the region where x is less than 4. Alright, so looking from this function, the first one or the second one, definitely the second one is correspond for x approaching 4 from the left. Okay, x approaching 4 from the left, then we use the function 8 minus 2x. So all you got to do here is just put in the value 4 inside this function. Okay, value 4, then you don't have to care anymore about minus here. This minus is showing that from the left, and it is as indicator for you to choose whether the first or the second function. So now we have chosen the second function because it's from the left, it should be somewhere where the value of x is less than 4. So we put in 4 inside, then what you're going to have? Minus 2 times with 4. So you will get 0. Alright? Okay, so done for limit x approaching 4 from the left. Then next we need to check what is the limit for x approaching 4 from the right. Okay, so as I said just now, okay, 4 is here. This one is for x approaching 4 from the left. And this is x approaching 4 from the right. So yang ni adalah region apa? X more than 4, right? So for the to determine limit, okay, x approaching 4 from the right, fx, we choose which function, the first or the second function? Definitely the first function, because this is for the x more than 4, right? So square root of x minus 4. So class, meaning that here x approaching 4 from the right, you are substituting 4x with 4, so 4 minus 4 you get 0. So what shall we conclude now? What is limit x approaching 4? Limit x approaching 4 of fx, for example number 2, for example 7, number 2 here should equals to 0. Why 0? Because it's satisfied. Limit from the left is 0, limit from the right also 0. Okay, if let's say just now we find out that limit from the left is not the same as limit from the right, then you maybe you can say that limit from the left is equals to 1 or 2, and then limit from the right is equals to 0. Then you cannot conclude that limit f as x approaching 4 is equals to 0. Okay, but now since both are the same, then yes, limit fs as x approaching 4 is equals to 0. Okay, now we come to the next subtopic here, which is discussing on the laws of limits. There are a lot of I think berapa altogether we have about 7 laws. Okay, so we have limit laws here. Okay, so if it is sum, meaning that you want to find the sum of the limit of between two functions, then you may separate them. Limit as x approaching a for fx plus gx, then you may find limit fx as x approaching a, then plus with limit gx as x approaching a. Same also for the difference. For the constant multiple, you may bring c out, because c, okay, c is a constant. It does not depends on x. Okay, for example, let's say I ask you limit 5x square, okay, as x approaching 2, for example. So in this case, 5 does not depend on x. Okay, 5 does not depend on x. So meaning that you can put 5 limit x square as x approaching 2, because 5 is a constant. Okay, it does not varies, or it does not depends on x. Okay, and then product limit, okay, also same as sum or difference just now. Limit of fx times gx, then you may put it as limit fx as x approaching a times with limit gx as x approaching a. And the quotient also same, you can find separately limit fx as approaching a over limit gx as approaching a, provided limit of gx as x approaching a, it does not equals to 0. And the power limit, okay, here limit fx power of n x approaching a, then you can find limit fx itself as x approaching a to the power of n. And the same thing for the fractional power. Faham tak apa maksud fractional power kat sini? Fractional power ni maksudnya power dia is not an integer. Macam x kuasa 2, okay, that is a power or polynomial, okay. But if let's say x power of 1 over 3, x power of 4 over 3, x power of apa, 4 over 3, 1 over 3, 1 over 2, and so on. As long as it is in terms of a fraction, then we call it as a fractional power. So you can put in this form as well, provided fx must be greater than or equals to 0. And if m is even, and n over m is reduced to lowest term. Don't worry about this. We're going to discuss this through an example, okay? Alright. Alright, and this is the details, okay? Limit laws for one-sided limit, okay? So if it is mentioned here, limit fx n over m as x approaching a from the right. From the right meaning that x more than a. From the left, okay, meaning that x less than a. Same also, only for one-sided also you can put for the whole, determine the limit to the power of n over n. Let me give you an example if you're confused here. Let's say the question asks you to find limit as x approaching apa 1, for example, for power x plus 1 power of 1 over 2. Okay, so for this case you can simplify the function. Jadikan dia maknanya limit x approaching 1, x plus 1, okay, everything to the power of 1 over 2. Okay, katakanlah soalan tu kata limit 1 from the left, then limit 1 from the left. Find the limit of function first, get the value. If it exists, then the result you put power of half, right? Okay. Okay, then here we have limit of linear functions. Okay, limit of linear functions here is very simple. If the function is a linear, what you got to do, then you just replace x with a. Okay, you just have to replace x with a. Let me give you an example. Limit x approaching 2, for example, and let me give you simple linear function. Linear, tahu kan, linear x plus 4, for example. So what you got to do to find this limit is very straightforward. It's going to be equals to 2 plus 4. Just replace x here with 2. Then you're going to have 2 plus 4 equals to 6. Okay, then the constant okay, ma plus b. Maknanya kat sini fx equals to mx plus b. We replace this x with a because x is approaching a. Okay, and then here assume p and q are polynomial, then the same also. Polynomial function also, if there is no problem, then the function you can just replace x with a, then you can decide its limit. Rational function also the same, okay, provided q a does not equals to 0. Okay, let me give you an example. Okay, limit x approaching 1, for example, x square plus 1 over x plus 2. So meaning to find the limit, you don't have to worry because first we put in x equals to 1 inside this function, the denominator. So x 1 tambah 2 is 3. So no issue, it's not going to be equals to 0. So to determine the limit, then straight away you can replace x with 1. So 1 square plus 1 over 1 plus 2. So what you get? You get 2 over 3, right? Okay, very straightforward. As long as there is no issue that when you substitute it's going to be equals to 0, then you can just proceed like this. Okay. Alright, so we're going to discuss this example 9 in the next part of the video. Okay, see you in the next part of the video to discuss example 9.